On July 1st, 2025, NASA's Atlas telescope in Chile, part of the Asteroid Terrestrial Impact Last Alert System, detected something unusual. At first, the object looked like just another moving dot against the backdrop of stars. It was labeled A11PL3Z, but once astronomers analyzed its path, everything changed. Atlas, unlike other surveys, has a special ability. It can scan the galactic plane, the brightest region of our galaxy where stars cluster most densely. Other telescopes often avoid this zone because it's too bright and overwhelming, but Atlas thrives there. That's exactly where this strange object was spotted, emerging from the direction of Sagittarius, making a direct line toward our solar system. Archived images from June revealed that multiple telescopes, including California's Zwicky Transient Facility, had actually recorded it earlier without realizing. Once the data was combined, astronomers calculated its orbit and found something extraordinary. It wasn't bound to the sun at all. Instead, its trajectory was hyperbolic, so steep and eccentric that it could only mean one thing. This was not a local asteroid. This was an interstellar visitor. Once astronomers pieced together observations from Atlas and other sky surveys, the verdict was clear. This object wasn't just another asteroid wandering inside the solar system. Its orbit was hyperbolic, meaning it wasn't circling the sun like the planets or comets we're used to. Instead, it was merely passing by on a one-way trip from interstellar space. Its eccentricity value measured around 6, far beyond the threshold of 1 that defines a gravitational escape trajectory. That number alone was enough to confirm its alien origin. At first, scientists debated whether it was an asteroid or a comet. But soon, images revealed a faint coma, a glowing cloud of gas and dust that forms when ices are exposed to sunlight and begin to sublimate. That sealed its classification as a comet, earning it the official designation C-2025-1 Atlas. This discovery was thrilling because only two interstellar objects had been seen before, Oumuamua and Borisov, and each one had raised more questions than answers. 3I Atlas suddenly became the next cosmic mystery, a messenger from another star system drifting through ours. The first question on everyone's mind was obvious: is this thing dangerous? Fortunately, the answer is no. Despite its interstellar origins and dramatic entry, 3I Atlas will come nowhere near Earth. At its closest, it will remain about 1.6 astronomical units away. That's more than 600 times the distance between Earth and the Moon. Safe for us, but still close enough for telescopes around the world to study in detail. Its closest approach to the Sun, or perihelion, will occur on October 30th, 2025. At that moment, it will swing inside the orbit of Mars, reaching just 1 point for astronomical units from the Sun before bending back outward on its escape trajectory. Unlike comets bound to the Sun's gravity, 3I Atlas will never return. It's a brief visitor, a once-in-a-lifetime opportunity for astronomers to catch a glimpse before it vanishes into the dark of interstellar space once again. If the orbit wasn't surprising enough, its speed certainly was. 3I Atlas is racing into our system at a blistering 58 kilometers per second. That's like crossing the length of 580 football fields every single second. By comparison, Oumuamua entered at about 26 kilometers per second and Borisov at around 32 kilometers per second. Atlas is moving nearly twice as fast, making it the fastest interstellar comet ever recorded. This extreme velocity means that the comet is not gravitationally bound to the Sun. Nothing will slow it down enough to keep it here. Instead, it will zip past and continue its journey across the galaxy, never to return. For astronomers, that makes the timing crucial. They only have a narrow window to collect as much data as possible before it disappears forever. Every observation counts, because who knows how long it will be before another interstellar wanderer crosses our path. After confirming its trajectory, astronomers turned their attention to the comet's physical behavior. Using telescopes from the Las Cumbres Observatory, they monitored its brightness over time. By tracking subtle changes in light, scientists can estimate how quickly a comet rotates and whether it has an irregular shape. For 3I Atlas, the results were fascinating. It appears to have a rotation period of about 29 hours. That means it takes just over a full Earth day to spin once on its axis. Even more interesting, its brightness barely fluctuated, only about 0.2 magnitudes of variation during its rotation cycle. By comparison, Oumuamua showed much more dramatic changes, leading scientists to believe it was elongated like a cigar or pancake. Atlas, on the other hand, seems to have a more uniform surface or a less irregular shape. But despite this stability, the comet is surprisingly bright. In fact, it is the brightest interstellar object ever recorded. It surged in brightness in late May 2025, increasing rapidly from magnitude 20 to around 17.7 to 17.8 in the Atlas O band. That brightness gives astronomers an easier time studying it, making Atlas a gift to observational science. Brightness alone isn't enough, size matters too. By estimating its albedo, or reflectivity, astronomers calculated that 3I Atlas has a nucleus about 10 kilometers wide. To put that into perspective, it's roughly an order of magnitude larger than Oumuamua and significantly bigger than Borisov, which measured just 1.2 kilometers in diameter. This makes Atlas not only the brightest, but also the largest interstellar object we've ever observed up close. Alongside its size, scientists noticed faint signs of activity. Atlas sports a small coma, that fuzzy halo of dust and gas created when solar radiation heats its icy surface. In addition, it has a short but noticeable tail extending a few arcseconds across the sky, pointing away from the sun at an angle of about 280. While not as dramatic as Borisov's 140,000 kilometers long tail, Atlas's tail still stretches over 25,000 kilometers, according to updated amateur measurements. This confirms that the comet is alive with sublimating ice and dust, even if its activity level is modest compared to some of its predecessors. Surface color is another vital clue to a comet's origins. 3I Atlas is noticeably redder than the Sun and slightly redder than the D-type asteroids we find in the outer regions of our own solar system. This reddish tint is typical of bodies rich in complex organic molecules, what astronomers call tholins, which form when simple ices like methane are bombarded by cosmic radiation over millions of years. The fact that Atlas has a coma complicates measurements because the reflected light we detect isn't just from the nucleus, it's also scattered from dust and gas in the halo. Borisov showed the same effect, where the coma's reflectance drowned out signals from the nucleus itself. Scientists are particularly interested in whether Atlas shares Borisov's carbon monoxide abundance, which hinted at formation in a cold, carbon-rich star system, possibly around a red dwarf. If future spectroscopy confirms a similar chemical makeup, it could suggest that Atlas and Borisov formed under comparable conditions, strengthening our understanding of the diversity of planetary systems across the galaxy. One of the most exciting aspects of astronomy today is how discoveries are no longer confined to the realm of large institutions. With modern telescopes, online platforms, and rapid data sharing, both professional and amateur astronomers are playing a role in shaping our knowledge of 3I Atlas. Networks like the Astronomer's Telegram provide daily updates where enthusiasts and scientists alike post their latest findings, images, and measurements. This collaborative environment has already led to significant refinements in our understanding of Atlas. For instance, amateur astronomers helped confirm that the comet's tail extends beyond 25,000 kilometers, far larger than early estimates suggested. They've also contributed stunning long-exposure images, revealing the faint coma and tail structure against star-filled skies. These efforts highlight how interstellar discoveries are now shared experiences, global events that inspire not only the scientific community, but also the public. In this way, 3I Atlas has become more than just a comet. It's a reminder of how curiosity and cooperation stretch across borders, uniting people in the pursuit of cosmic knowledge.
Every time an interstellar visitor enters our solar system, astronomers get a rare chance to test their models. With only 3 confirmed detections, Oumuamua, Borisov, and now Atlas. Each object carries enormous weight in shaping our theories. One striking outcome of Atlas's discovery is a new estimate of interstellar object density. Based on 3 years of Atlas survey data and only 1 detection, scientists currently infer a density of around 0.001 objects per cubic astronomical unit of space. That's a dramatically lower number than earlier predictions. But this figure could change. It's possible smaller or less active objects slip past our detection methods, or that these wanderers are more common in certain regions of the galaxy than others. Still, the implication is sobering. Interstellar comets are likely rarer than we hoped, which makes every single one we detect an invaluable scientific opportunity. By comparing Atlas's modest activity with Borisov's hyperactivity and Oumuamua's mysterious inactivity, astronomers are piecing together a broader picture. Interstellar bodies are highly diverse, each shaped by the unique conditions of their birth systems. And in studying them, we learn not just about these visitors, but about how planetary systems, like our own, form and evolve across the galaxy.
Although Atlas is racing through our solar system at breakneck speed, astronomers still have several months to gather data. Its perihelion on October 30th, 2025 will mark the highlight of its visit as the comet reaches peak solar heating and possibly becomes more active. After slipping behind the sun, it will re-emerge in December, giving Earth another window to track it before it disappears forever into interstellar space. For those without access to telescopes, NASA's JPL Horizon system already offers tools to track Atlas's path in real time. Meanwhile, researchers will be watching closely for signs of outgassing, composition changes, and shifts in brightness that may reveal its structure and chemistry. The ultimate goal is to piece together its origin story. Did it form around a red dwarf star, like Borisov likely did? Or does it represent an entirely different type of interstellar environment? Whatever the answers, one thing is certain: 3I Atlas is a rare cosmic messenger, a piece of another solar system hurtling past our own. In a universe where such visitors may only appear once in decades, it's a privilege to witness this fleeting encounter. For scientists, it's a golden opportunity to learn. For the rest of us, it's a reminder that the galaxy is alive with wanderers, and every so often, one comes close enough to say hello.